Right, greetings everyone. It's Mr. Shajwayo here. Welcome to Back to Basics. What is it that we are doing? We are doing our, this is going to be our June 2018 paper, right? This is June 2018 paper. We're still looking at our grade 10 Euclidean geometry, right? Now, what is it that we are going to do here? They say in the diagram below, you are given a quadrilateral ABCD where AB, it is given that AB is equals to what? Or AB is parallel to CD, right? You can see from this science here, which shows that these two are parallel to each other. And now they say B is equals to X and C is equals to 120. Now they want you to prove that also your what? Your AD is going to be parallel to what? Your BC, which means they want you to prove that also these two are going to be parallel to each other. Now, what is it that you're going to do to prove that? Now, I want you to start with this. Now, you can start by applying this. We can start by applying the parallel lines that we are already given here, right? Can you see that your x plus your 120 degrees is going to be equals to 180 degrees, right? Because this is co-interior angles. Remember, these lines are parallel, right? So which means co-interior angles, they're what? They're equals to 180 degrees. So these are going to be interior angles, right? Why is it called interior angles? Because here they gave us that AB is parallel to what? To CD altogether. So which means now your X is going to be same as what? It's going to be equal to same as 60 degrees. Right now that we found out that our X is 60 degrees, what is it that you're going to do? Which means now your angle B is going to be close to 60 degrees. And now your angle A, remember your angle A is going to be 2 multiplied by what? By 60 degrees. Now, I want you to look at something. If you can add your angle A plus your angle B, what is it that you're going to get? You are going to have, remember your angle A is 60 multiplied by 2, which is going to 120 degrees, right? So which means now your angle A is 60, or rather your angle B is what? Your angle B is 60, your angle A is 120. So you're having 120 degrees plus 60 degrees, right? Which means now when you add these two angles, they are giving you 180 degrees. So if these two angles are giving you 180 degrees, therefore you can conclude what? You can conclude that your what? Your AD is going to be parallel to your BC because of what? Co-interior angle, right? Co-interior angle are equal to what? Are equal to 180 degrees. Can you see that you've proven that these co-interior angles here, they are adding up to 180 degrees. So therefore, this line, which means this line is also what is going to be parallel to that one, right? So basically, that is going to be the reason that we are going to use to prove that. Now, they say now from here, what is it that you are they want you to do? They say in number 2, what type of a quadrilateral is this? Give a reason. Now, remember you've already found out that all these sides here are parallel and all these sides are, or rather, and also the interior angles here, they are what? They are equal. Can you see that this angle here is 120 degrees and this angle here is 120 degrees, right? So which means this can only be what? This can only be a what? This is going to be your parallelogram, right? This is going to be your parallelogram. Lelogram. Why is this going to be your parallelogram? Now, what is this? Because look, your opposite side, your opposite sides are what? Are parallel, and also what? Your opposite sides are parallel, and also what? Your opposite angles are also equal. Your opposite angles are what? Are equal altogether. So that is going to be some of the reasons that makes this particular you know shape to be your parallelogram, right? Now let's look at the next question. Let's look at question 5. They say now in the diagram below, ABCD is a parallelogram. CR bisects CDE, right? Now when they say CR bisects CDE, which means basically they are saying your angle C1 here is equal to your angle C2 here, and they are saying your CR is parallel to what? To your BD. Right now, let's see. So they want you to prove that your BC, right? Your BC is going to what? Your BC is going to be close to your CD. Now, how can we go about improving that, right? Now, because they want us to prove that your BC is equals to what? Is equals to CD. Now, the easier thing that you can prove here, to prove lines that are equal to each other, you must prove that the interior angles, or the angles that are going to be opposite to those lines, are equal, right? So which means now you must prove that your angle D1 is actually angle D2. Then you can conclude that your BC is equals to DC, right? That's the easier way of just proving that. Now, how can we then go about improving that? I want you to start here. I want us to start here. We can start by saying, look, our angle C1, can you see that our angle C1 is going to be close to our angle D1, right? And what is going to be the reason here? This is going to be your alternating angles. Why are these angles alternating, right? Because your BD, can you see that your BD is parallel to what? It's parallel to our CI altogether. So that's going to be the first reason. Now, what else now can you do? I want you to check here. Can you see that also your C2, or rather your C1, is also going to be close to your, what, your C2? Your C2, remember that one, because they told us that your CR, right? It is given that your CR bisect, right? Bisect angle what? Bisect angle CDCE altogether. So therefore, which means it makes these two angles to be equal to each other, right? Because bisect, it means it cuts these two angles into what? Into equal halves. Now, I want you to also look at the way that, can you see that your angle C2 now, your angle C2 is going to be exactly the same with your B2, because these are going to be corresponding angles, right? Your C2 is going to be close to your B2, which is going to be corresponding angles, right? Now, so this is going to corresponding because again your BD is parallel to what? To CR. And as soon as you got that, what is it that then you can do now? Then you can now provide a conclusion that, look, your angle what? Your angle D1, the angle D1 is going to be close to your angle B2, right? Now, and then you can just then conclude that, remember, your D1 is equal to your angle B2, you've already proven, right? Now, then you can then conclude that, look, my BC is going to be equals to my CD, because these are going to what? These are going to be you know side opposite to equal angles. Altogether, this is going to be side opposite to what? To equal angles. Side opposite equal what? Equal angles. Remember, when the side is opposite to equal angles, therefore it makes this side to be also equal to this particular side, right? Hopefully this makes sense to you now. Let's look at 5.2. Now in 5.2, what is it that they are saying? They say prove that ABCD is a rhombus, right? Now, to prove things being a rhombus, basically you must prove that all the sides are going to be equal, right? All the sides are going to be equal. This one is almost going to be very easy, because we've already proven that these two sides are equal to this one, right? So which means the only thing that you can do, that you can start with them actually to say my BC is equal to my CD. This one is already proven, isn't it so? This one is already proven, right? And also, can you see that my CD is going to be equals to my side what? Is going to be equals to my side AB. This is going to be, what is the reason there? This is going to be opposite side of a what? Of a palm. Remember that your parallelogram produces sides that are equal to each other, which means, yes, this side is going to be equal to this side. And the same is true. You can also say, look, my AD is also going to be equal to my BC. And what is going to be the reason there? This is going to be what? My AD is going to be parallel to my BC. This is also going to be opposite side of a what? Of a palm, or rather of a parallelogram, right? Is going to give you that. And now, which means now all these sides, can you see that all these sides are equal to each other, right? So you can just now provide conclusion that your AB CD is a rhombus, right? Is a rhombus. And what is going to be the reason that one being a rhombus? It's because all four sides are equal. All four sides are what? Are equal. right? So if all the sides are equal, therefore everything there is going to be equal. Hopefully this makes sense to you now. Let's just go swiftly now to our 5.2 and see in terms of what is it that you can do in our 5.2. Now, in our 5.2, let's look at it. Let me just look at here. All right. Now, in our 5.2, what is it that you are going to do here? Well, the question here, it wants you to prove that your AC is equals to 10 centimeters. We are not given that your AC is 10. The question basically requires you to prove that if all these sides are given, that BT is 20, 4 and or your AB is 13, therefore your AC is going to be close to your 10 centimeters. How can you go about proving that? Now, let's start here. I want you to note that your BO, let me just remove all these things so that you can see proper, right? Let me just remove all these other things, right? So that you can see here. Now, I want you to have an understanding that, look, my BO firstly, my BO is going to be equals to what? My BO is going to be equals to my OD, which is going to be what? Both of these are going to be 12 centimeters, right? This is going to be the reason because you know that the diagonals of your rhombus what bisect each other, right? So that's the reason why these are going to be equal to that, right? Now, secondly, what else then now are you then going to do from here? Now, I want you to note that this angle O here, your angle O, remember that the diagonals of your rhombus, they meet at 90 degrees, right? So your angle O is going to be equal to 90 degrees, right? Because diagonals bisect each other at what? At 90 degrees, right? Now, they bisect each other at 90 degrees altogether. Then that's going to be the reason behind this, that diagonals now bisect each other at 90 degrees. Now, so as soon as you get that, which means now you can just use what? You can just use this to find out what is going to be this one, right? You can use your theorem of Pythagoras to look at this particular triangle, right? Can you see that this is your right angled triangle? You already have this being equals to your 12, right? So you can find out what is going to be your AO. So you're going to say your AO squared, right? Can you see that your AO squared is going to be equals to what? Your AD squared subtract your what? Subtract your OD squared. Then the reason here it's going to what? It's pi theorem, right? This is going to be your theorem of Pythagoras, right? Now from here, what is that you're going to do? You are going to say, look, what is going to be my AO? Remember, this is AO. So this is going to be same as 13 squared subtract. This one is going to be 12 squared. Remember, 13 squared is same as 169. So this is same as 169 subtract 144, which means this is going to give you your 25. Then the square root of 25 and your AO squared, you look for the square root, which means your AO is going to be equals to what is going to be 5 centimeter. Now, as soon as AO is close to 5 centimeter, therefore, you know that your what? You know that your AO is going to be equals to your CO. What is the reason there? Because diagonals do what? Diagonals bisect each other, which means they are both equals to 5. So, which means therefore, if this is 5 here and this is 5 here, which means your AC is going to be equal to 5 plus 5, which is going to be 10 centimeter altogether. So basically, that is going to be how you are going to get the value of your AC. Hopefully, this makes sense to you now. And thank you very much.